H parameters of two-port circuit or hybrid parameters of two-port circuit. For this two-port network, the equations for H parameters are V1 equal to H11 I1 plus H12 V2. This is first equation, and the second equation is I2 equal to H21 I1 plus H22 V2. In the matrix form, we can write these two equations in matrix form. This matrix is hybrid matrix or H matrix. Now, H11 is the ratio of V1 to I1 when V2 is 0. H11 is the ratio of voltage to current, so its unit is ohm, and it is the input impedance, because it is the ratio of voltage to current of input port or port 1 when port 2 is short circuited. H12 is V1 over V2 when I1 is 0. It is the ratio of voltages, so it is unitless quantity, and since it is the ratio of voltage at input port to output port, so it is called reverse voltage gain. Because voltage is transferring from output port to input port. That's why it is reverse voltage gain. Next is H21. It is the ratio of I2 to I1 when port 2 is short circuited. It is the ratio of currents, so it is unitless quantity, and it is called forward current gain. Because it is the ratio of output current to current of output port to current of input port, or current is transferring from input port to output port. That's why it is forward current gain. And H22 is the ratio of I2 to V2 when I1 is 0. It is the ratio of current to voltage, so its unit is mho, and it is called output conductance, because it is the ratio of current of output port to the voltage of output port. That's why it is called output conductance. Now we can draw the equivalent circuit for the equations of H parameter. In the first equation, on the left hand side we have voltage, so the two terms on the right hand side are also voltages, and sum of voltages is possible in series connection. So V1 is the voltage of input port and port 1, and current of port 1 is I1 into H1. H11 I1 is the voltage. So here we have a resistance or impedance H11, and the second term as V2. V2 is the voltage of port 2. So in port 1 side we need to have H12 V2. So we will connect a voltage dependent voltage source, and its value is H12 V2. Now in the second equation, on the left hand side we have current. So on the two terms on the right hand side are also current, and sum of currents is possible in parallel connection. Um, the second term is H22 V2. V2 is the voltage of port 2. So H22 is connected here between 2 and 2 dash. H22, and it is conductance, so its unit is mho. And the first term here is H21 I1. I1 is the current of input port. So for this term we need to connect current dependent current source in parallel with H22, and the value of current dependent current source is H21 I1. So this is the equivalent circuit for the equations of two-port network. Equations of two-port network in terms of H parameters. Now we will write Z parameters in terms of H parameters, or it is the conversion of H parameter to Z parameter. The equations for Z parameters are V1 equal to Z11 I1, Z12 I2. This is first equation. Second equation is V2 Z21 I1 plus Z22 I2. Similarly, we have equations for H parameters. V11, in fact V1 equal to H11 I1, H12 V2, and I2 is H21 I1 plus H22 V2. Now we have to write Z parameters in terms of H parameters. So we will modify equation 3 and 4 in the form of 1 and 2. So we can see that in equation 2 we have V2 I1 I2, and in equation 4 we have V2 I1 and I2. So we will just reshuffle the equation 4 to write in the form of equation 2. So this is I2 minus H21 I1 equal to H22 V2. So V2 is minus H21 over H22 I1 plus 1 over H22 I2. Now this equation is in the form of equation 2. So by comparing equation 2 and this fifth equation, we can write Z21 as negative H21 over H22 and Z22 as 1 over H22. Now for Z11 and Z12 we need to have equation with terms V1, I1 and I2. So we'll replace V2 from equation 5 to equation 3. So V1 is H11 I1 and then H12 and V2 from equation 5. Negative H21 over H22 I1 plus 1 over H22 I2. So V1 equal to H11 minus H12 H21 over H22 I1 plus H12 over H22 I2, and then take the LCM. LCM is H22. So this one is H11 H22 minus H12 H21 into I1 plus H12 over H22 I2. Now this equation is in the form of equation 1. So we can simply compare equation 1 and 6. This will give Z11, which is equal to H11 into H22 minus H12 H21 over H22. And this H11 H22 minus H12 H21 is the determinant of H matrix denoted by del H over H22. And Z12 is H12 over H22. So that's how we convert or we write H parameters in terms of Z parameters in terms of H parameters. Now we will write the condition for reciprocal two-port network. Reciprocal two-port network or circuit. And the condition for reciprocal two-port network is V1 over I2 when I1 is 0 must be equal to V2 over I1 when I2 is 0. In terms of Z parameter, it is Z12 must be equal to Z21. Now we have Z parameters in terms of H parameters. So replacing Z12 by H12 over H22 and Z21 by negative H21 over H22. So this will give the condition for a reciprocal two-port network in terms of H parameter, which is H12 equal to negative H21. This is the condition for reciprocal two-port circuit in terms of H parameters. Now we will write the condition for symmetrical two-port network or two-port circuit. Condition for symmetrical two-port circuit is V1 over I1 when I2 is 0 must be equal to V2 over I2 when I1 is 0. In terms of Z parameters, it is Z11 must be equal to Z22. Now replacing Z11 by this del H over H22 and Z22 by 1 over H22. This will give del H must be equal to 1. Del H is the determinant of H matrix. So condition for symmetrical two-port circuit in terms of H parameters is determinant of H matrix must be equal to unity. Now we will find out the H parameters for few two-port circuits. In this two-port circuit, between 1 and 2, resistance R is connected. Voltage of port 1 is V1, current is I1, voltage at port 2 is V2, current is I2. And we have to find out the H parameters for this two-port network. So the two equations are for H parameters V1 H11 I1 plus H12 V2, and second equation is I2, which is H21 I1 plus H22 V2. Now we need to write two equations in these two forms. So let us apply KVL, or we can KVL, rise in voltage V1, then drop across R1, which is R I1, and then drop V2. Rewriting this equation, V1 equal to R I1 plus V2. Now if we compare equation 1 and 3, then this will give H11 as R and H12 equal to 1. Now From the circuit we can see that this I2 is negative I1. I2 is negative I1. So this I2 is negative I1 plus 0 V2. Now we'll compare equation 4 with equation 2. Then this will give H21 as minus 1 or negative 1 and H22 0. So in this way we can find the H parameter for the given circuit. Now let's take another circuit in which 1 and 2 terminals are short circuited, 1 and 2 dash short circuited, and resistance R is connected between them. Now voltage at port 1 is V1, current is I1, voltage at port 2 is V2 and current is I2. Again we will write equations in the form of equation 1 and 2. So we can see that V1 here path is short circuited, so V1 is equal to V2. If we modify this equation, then this will be V1 equal to 0 I1 plus 1 V2. Now if we compare equation 5 with equation 1, then this will give H11 0 and H12 1. Now current through this resistance R is I1 plus I2. Now apply KVL in this loop. This will give V2 rise in voltage, then drop R I1 plus I2 equal to 0. So this equation is V2 minus R I1 minus R I2, or R I2 is minus R I1 plus V2, or I2 is negative 1 I1 plus 1 by R V2. Now we will compare the equation. This equation has I2, I1 and V2. Equation 2 has I2, I1 and V2. So comparing equation 6 with equation 2, this will give H21 negative 1 and H22 1 by R. So that's how we find the H parameter for this two-port network. Now let's do the analysis of terminated two-port network. Analysis of terminated two-port network or two-port circuit. Terminated two-port circuit means the port 2 or output port is terminated at load impedance ZL. And at input port, external source is connected with voltage Vg in series with impedance Zg. Voltage at port 1 is V1, current is I1. Voltage at port 2 is V2 and current is I2. Here we have to find input impedance Zi, which is V1 over I1, output impedance, which is V2 over I2 when Vg is 0. At the same time, we will also find out current gain, which is load current over input current, IL over II, or we can write minus I2 over I1, and the voltage gain, which is V2 over V1 or V0 over Vi. So we will start with the input impedance Zi. Equations for H parameters are V1 equal to H11 I1 plus H12 V2. This is first equation. Second equation is I2, which is H21 I1 plus H22 V2. So input impedance is basically a ratio of V1 to I1. So in the first equation, we will replace V2. So from the output side, we can see this V2 is negative ZL I2. Now replacing this V2 from 3 to 1. So V1 is H11 I1 plus H12 into negative ZL I2. Oh, but okay, uh, I made a mistake. Replacing this V2 from 3 to equation 2. So I2 is H21 I1 minus H22 ZL I2. So 1 plus H22 ZL I2 is H21 I1. So this will give I2 equal to H21 over 1 plus H22 ZL I1. So again we can write this V2 in terms of I1 if we replace I2 from equation 4 to 3. So V2 is negative ZL H21 I1 over 1 plus Z22 ZL. Now replacing this V2 from equation 5 to equation 1, this will give V1 H11 I1 negative ZL H12 H21 I1 over 1 plus H22 ZL. So V1 over I1 is input impedance and it is equal to H11 minus ZL H12 H21 over 1 plus H22 ZL. This is the expression for input impedance. Now let's find out the expression for current gain. So this current gain is simply negative I2 over I1, and from equation 4 we can see that I2 over I1 is H21 over 1 plus H22 ZL. So current gain is negative H21 over 1 plus H22 ZL. This is the expression for current gain. Now let's find out the expression for voltage gain. So AV is basically V2 over V1, and we can see that V2 is negative ZL I2. And what about V1? This V1 is ZI into I1, and negative I2 over I1 is current gain. So voltage gain is basically ZL over Zi into AI. So this is the expression for voltage gain. Now let's find out the expression for output impedance. For that we need to make Vg 0. So first let's make Vg 0. If Vg is short circuited, Vg is short circuited and output impedance is the impedance of the circuit looking from the port 2. So we will remove this load impedance. Now we need to connect external source to activate the dependent source of this two-port network, and the value of the dependent source is V2, which is providing current I2. So the ratio of V2 over I2 is the output impedance. Now from the input loop we can see that V1 is negative Zg I1. Now we need to have the equation in terms of V2 and I2. Okay. Now we will replace V1 in equation 1. So this will give negative Zg I1 equal to H11 I1 plus H12 V2. So this is negative Zg plus H11 I1 equal to H12 V2, or this I1 is negative H12 over Zg plus H11 V2. Here we have I1 in terms of V2. Now replacing this I1 in equation 2. So I2 is negative H21 H12 over Zg plus H11 into V2 plus H22 V2. So this is okay, I2 equal to H22 minus H21 H12 over Zg plus H11 into V2. So Z0, which is V2 over I1, V2 over I1 is 1 over H22 minus H21 H12 over Zg plus H11. This is the expression for output impedance. So that's how we do the analysis of terminated two-port network. Now for the given two-port circuit, we have to find out the H parameters. Equations for our H parameters are V1, H11 I1, H12 V2. This is first equation. Second equation is I2 equal to H21 I1 plus H22 V2. Okay, so from this circuit we will try to write two equations in the form of equation 1 and 2. So let us apply KVL in this loop. Rise in voltage V1, then drop across 10 ohm resistance, which is 10 I1, and then drop V2. That is equal to 0. So V1 is 10 I1 plus V2. Now this equation is in the form of equation 1 because it has V1, I1 and V2. So by comparing equation 1 and 3, we can find out H11 and H12. So H11 is 10 ohms and H12 is 1, which is reverse voltage gain. Now we have to write equation which includes I2, I1 and V2. Now for that purpose, apply KVL in this loop. Rise in voltage V2, and then see current through 20 ohm resistance is I1 plus I2. So rise in voltage V2 and then drop across 20 ohm resistance, which is 20 into I1 plus I2 equal to 0. So V2 minus 20 I1 minus 20 I2 equal to 0, or 20 I2 is minus 20 I1 plus V2. or I2 is minus negative 1 I1 plus 1 over 20 V2. Now this fourth equation uh, is in the form of equation 2 because it has I2, I1 and V2. So now comparing equation 2 and 4, H21 is negative 1 and H22 is 1 over 20 more. So that's how we find out the H parameter for the given two-port network. Now let's see another example. For this given two-port network, we have to find the H parameter, and this two-port network is basically an ideal transformer with turn ratio n to 1. Now we know that the for transformer turn ratio is n to 1. So see, this is basically n1 to n2. So for transformer, ideal transformer, V1 over V2 is n1 over n2, and this direction of I2 is coming into the secondary. So negative I2 over I1 is n2 over n1. So V1 over V2 is basically n, and negative I2 over I1 is 1 over n. And the equations for two-port network or equation for two-port network in terms of H parameters are V1 H11 I1 plus H12 V2, and I2 is H21 I1 plus H22 V2. This is 1 and this one is 2. Now we have two relations, and we will modify these two relations in the form of equation 1 and 2. So from this, suppose this is A and this one is B. In equation A, we can write V1 equal to 0 I1 plus n V2. Now this equation is in the form of equation 1 because it has V1, I1 and V2. So by comparing equation 3 and 1, we can find out H11, which is 0 ohm, and H12 n. H12 is n. Now from the equation B, we can write I2 as negative 1 over n I1 plus 0 V2. This is equation 4, and this equation 4 is in the form of equation 2 because it has I2, I1 and V2. Now by comparing equation 2 and 4, we can find out H21 as 1 over n and H22 is 0 more. So that's how we find out the H parameters for an ideal transformer with turn ratio n to 1.